All right, so this is part 2. We're still on 5.2 and 5.3. We stopped off goal 3, using concurrency of perpendicular bisectors. So what's happening is we have a triangle. All right, triangle A, B, C. And what it's telling you is if we have 3 perpendicular bisectors. So I'm going to put my perpendicular bisectors in orange. All right. So I have this perpendicular bisector, and I have this perpendicular bisector. I didn't draw this very well. My bad. And this perpendicular bisector. For this one, it's not going to be perfect. Forgive me. Okay. So we have 3 perpendicular bisectors. And they all meet at that point, and we already know the name of this point. This point is called the circumcenter. All right. So what this theorem that we're talking about is telling us, if we have a point of concurrency, our circumcenter of 3 perpendicular bisectors, then what I like to call them, my angle segments, they're all congruent. Or if you prefer to say, equal. So all of these green lines are going to be equal. So an angle segment goes from the angle to our point of congruency, our circumcenter. All of these are the same. Boom, boom, boom. So we're dealing with a circumcenter, okay? The angle segments are equal. So if we're dealing with a circumcenter, angle segments are equal. So knowing that, find the indicated length here. So what your problems will say on your homework is it will say that point G is a circumcenter. So as soon as you see the word circumcenter, all right, you should know angle segments are equal. So if G is my circumcenter, I want to go ahead and identify my angle segments, the ones going to the angles. So that would be AG, BG, and CG. And next thing I want to see is, do I know what one of them is already? Yes, I know AG is 9. Well, if AG is 9, what can you tell me about all the other green segments I have here? They are also 9. This is 9, and this is 9. So it wants us to find BG. Well, how much is BG? Well, let's see. Bing! BG equals 9. Now, this is a question on your homework. Remember, on your homework, to just type in the number. This is all you would type in for your answer. 9. Okay? You only have 2 problems like that, and one of them I've already done for you. So there you go. All right, let's continue on with goal number 4, our angle bisector theorem. So you remember whenever I did the perpendicular bisector theorem, I broke it down into 3 parts. I'm going to do the same thing here for our angle bisector theorem. So let's say we have an angle bisector. Okay, the first thing we're looking for is the actual bisecting of the angles. Okay, we're looking for 2 congruent angles. I've done that here in this beautiful rust color. All right, the next thing we're looking for is 2 90-degree angles. Where are these going to happen? Well, they're going to happen when you're looking at the figure right here. They have to be on the sides of the angle itself. Okay? And then the third thing you're looking for is 2 congruent sides. Now, what 2 sides are we looking to be congruent? These right here. Because what our angle bisector theorem tells us is that if we have an angle bisector, then the ray is equidistant from the sides. So that's why we have to look for these right here. This right here is equal distance from our sides. Okay? So knowing that, and remember the rule is, if you have 2, guess what? You have all 3. So any mix of the 2, what? You better not stop working. No! Hold on, guys. Let me pause it. And maybe I can fix it. Maybe, I don't know. Sphere. Why did you stop working? Look at my old videos. Okay. Did my recording stop working too? I don't see my little record button. But I see my little dotted box. That means I'm being recorded. I'm killed. I hope I'm not just wasting y'all's time right now. What else is trying to go? Y'all got to see my Chris Evans collage up on my screen, didn't you? Hey! Why isn't this working? Okay, alright. I don't know how much you missed. Actually, I kind of have an idea. So I'm just going to quickly review goal 4 again using angle bisectors theorem. We're looking for 3 things. We're looking for 2 congruent angles that are in the same position as these, 2 90-degree angles, same position as those, and 2 equal sides. Remember, if you have any mix of the 2, you have all 3. Alright, so let's continue. Example 4, find the indicated measure. So they want to know what is the measure of angle ABD. So here's what they want to know right there. Alright, so first thing I notice is I have 2 right angles. That's good. That's good. I like that. I also notice I have congruent sides. I like that too. Because remember, if I have 2 of them, I have all 3, which means I have 2 congruent angles. That means that these angles right here are the same. So if this one's 20 degrees, our question mark is also 20 degrees. Now, when you type this in on your homework, just type in the 20. Please do not type in the degree sign. 20 is all you would put in. Okay? Let's continue on. Remember, if you have 2, you have all 3, and that's what's going to help us right here. So we want to solve for x, and we need to figure out what to do with our algebraic expressions here to be able to solve for x. So the first thing I notice, I have 2 congruent angles. They're in the right spot. That's good. I also notice I have 2 90-degree angles. So remember, if I have 2 of them, I have all 3. So that means I have equal sides. So I can solve for x by setting those equal. I can say 3x plus 1 equals x plus 11, and then solve it doing my variables and constants. So I have 3x over here. I need to move this x over. I have 11 over here. I need to move this 1 over. So 3x minus x is 2x. 11 minus 1 is 10. Then we divide by 2. And we get x equals 5. Now, this is a question on your homework. All you're going to type in is 5. Do not put x equals 5. Just put 5. All right? That is the only way you're going to get the right answer. So I'm going to know if you get the wrong answer that you didn't watch the notes video and you didn't listen to me. That will be lovely. All right, and then our last goal for today, goal number 5. We're going to be talking about congruency of angle bisectors. So again, we have a triangle. And we're talking about what's going to happen if we have 3 angle bisectors intersect. So let's say we have this right here. Here's an angle bisector. We have this right here. There's an angle bisector. And we have this right here. There's an angle bisector. Where they all intersect, this one point right here, is called our incenter. And what our theorem tells us is from that incenter, you go from the incenter and you create the perpendicular segment, or if you prefer to call it, the box line. Tell you what about all these box lines? They are equal. So if we go from that incenter to the side and we create a box like so, all of these are equal. Okay? So if you see incenter, remember box lines are equal. So knowing that, let's look at example 6. I would tell you right now that this point here, Sugarfoots, I didn't fill in all of that now, did I? Silly Jackie. Tricks are for kids. Hold on. All right, now it's all filled in. I would tell you right now that point D is an incenter. So instantly when you see that word incenter, you need to remember our box segments are congruent. So all of these segments with boxes, also known as being perpendicular, are the same length. They want to know how much is DB. Remember, all of these that are blue squiggles are the same length. So if this one's 9, how much are these? Well, that one's 9, and that one's 9. So how much is DB? DB equals 9. And just like before, when you type this into Google Forms, just type in 9. Do not type in anything else. So when you see incenter, box, lines are equal. All right. Thanks, guys. Sorry about the 2 videos. Next week will be shorter, promise.